And then I'm going to tell you what needs to be on your flashcard. Now, you are right now looking at this BFF sheet and thinking, oh my gosh, do I have to memorize all of this? And the answer is no. Now, do you need to know how to figure out this stuff? Yes. But the only thing you have to memorize is what I'm going to put on the board. Okay? So what I put on the board is memorization. That's what's going to go on your flashcards. But right now, we're putting it on our sheet so that we have everything in a concise little spot, and then we can transfer that to our flashcards, since your flashcards are ready. Notice, the first BFF, there are 12 of them, the first BFF says the identity function. This one is also sometimes called the linear function. You need to know one name. I don't care if you call it identity, I don't care if you call it linear. But the reason it's called the linear function is because it is the only one that is shaped like a line. So draw that picture. On your grid, as best you can, draw that picture. Now, up next where it says identity function, see where it says y equals? The equation is y equals x. You already knew that, I think, but just in case you didn't, now you do. Y equals x. So you're going to make a note card. There are 3 pieces of information that go on the note card. I don't care how you arrange it. It's your note cards you're going to study, your flashcard. 3 pieces. So maybe you have name on the front and graph and equation on the back. Or maybe you have name and equation on the front and graph on the back. I don't care. But those are the 3 things that you're responsible for. All right, what's the second one? Guys, it says it's called the squaring function. See where it says squaring? Its picture is this nice little parabola. This is the origin, and its equation is y equals x squared. We're going to come back and talk about what all the rest of that means. But right now, this is all we're doing. All right, and then we've got our cubing function. Now, watch while I graph this, because I am a little picky about how you draw it. It needs to be kind of going the right way. So when I draw it, I'm coming up and curving into the origin, and then I'm twisting my hand and curving up like that. See how it's kind of a snaky thing? Squiggly. That's the shape, that's the cubing function, and its equation is y equals x cubed. Is that okay? What's next? What? Reciprocal function. All right, so the reciprocal function has a picture that's kind of different. So you're going to make an asymptote right here on the y-axis. That's x equals 0. And then on the x-axis, which is y equals 0, so you're going to make 2 asymptotes. And then you're going to have a shape up here like this, and a shape here like this. I don't know if you guys talked about these last year. That's called a hyperbola. That's a hyperbola shape. But you just need to know the reciprocal function looks like this. And its equation is exactly what you'd expect, 1 over x. Next, we have our square root function. Don't get this mixed up with squaring, it's a different thing, it's square root. So you have a dot at the origin, and watch where I'm arcing. I arc out like this. Don't go like this, it's not like that, it arcs out. And it's the square root of x. The exponential equation is y equals e to the x. Its equation, or its graph, has an asymptote at y equals 0. Please label your asymptotes, guys. Thank you. Label your asymptotes. Y equals 0. An intercept at 0, 1, so a point right here at 0, 1. And then it does this. So it follows the asymptote as it comes out here. It gets closer and closer. But then over here, it shoots up into space. So sometimes if you're reading maybe a magazine report or newspaper report, don't talk about exponential growth. This is exponential growth. Just zoom. Okay, we're half done, guys. You're doing great. For the natural logarithmic function, I'm okay if you just refer to it as the logarithmic function. You don't, this is going to be the picture for every logarithm, not just the base C logarithms. So its equation is ln x or log x, whatever you prefer. This is natural logarithm, this is other logarithm. Either one of those is fine with me. It's a logarithm. And then the picture has some similarity to that one, but it's twisted. So your asymptote now is at x equals 0. Your intercept is at 1, 0. And it arcs out like that. Now we have our two trigonometric BFFs. There are actually 6 trig functions, but sine and cosine are biggies, so that's why they're included. So there's sine and cosine. I'm going to have you do them together picture-wise because they're very, very similar. The equation for sine x is sin x. Please don't say sin. That makes you sound goofy. It's sine x. It looks like sin, but it's sine x. Y equals sine x. And then y equals cos x, cosine x. Those are the equations. The graph paper that I provided you with is very small scale. I mean, the boxes are really tiny. So I would like to have you maybe count up like 3 or 4 boxes and call that 1. So in other words, change the scale because the whole sine curve happens between -1 and 1. And if you try to do it on your paper, it's just going to be all squished up in there. So I'm just spreading it out. This is -1 and this is 1. put a dot at the origin, draw a hill that goes up to 1 and then comes down. Then draw a valley that goes down to -1 and up to 1. And then the same thing in the other direction. So here's my valley and here's my hill. There are arrows on the end of that, boys and girls, because the sine curve goes on forever and ever. Last year's Math League t-shirts said catch the wave, and they had the sine curve drawn on there. All right, everybody got it? Because I'm going to step over here and I'm going to do the cosine. So I'm going to do the same thing. I'm going to go up 3 or 4, whatever works for you. We call that 1 and -1.
I'm not talking about that. Every chick that I was talking
Who has yellow lanyards?
Freshman.
Okay, now the cosine curve looks just like the sine curve, except your dot to start goes up here. See where I am? And then I'm going to come down all the way to -1 and back up again. And however much room you have, you can keep going. So your hills go down to -1 and up to 1, just like they do over here. These two shapes are exactly the same, except what? Shift it over. We're in chapter 4 going to spend days graphing sines and cosines. So it's really important that you can keep them straight. I don't know how you'll do it, being the weirdo that I am, good Catholic girl. Original sin reminds me that the sine goes through the origin. Somehow you have got to remember that. This one is the sine, and this one is the cosine. Okay, you got 3 more to go. We'll hit those after lunch. Don't forget, maybe you'll get change at lunch and you can sign up for Math League. Gotta get that taken care of. I will see you back at 49. You're back in your seats at 49.